Hi guys. So we're gonna have a look at some questions related that you have learned in week 9 and maybe in week 8 as well. So question 5. I'm starting question 5 because you've done question like we've done questions 1 to 4 like already almost related to the recurrence formula and solving them in the previous weeks, and the YouTube videos are existed related to them. So here you got white keys. So I can call them A, and the other one is black one. So the number is given to us 52, and this one is 36. And the question asks us how many single notes can be played. All right, so the single notes, so we will choose one of them. So we follow the inclusion exclusion principle. So we're gonna have this one and A, B, and what about the A intersection with B? So we can understand easily that this is empty set because we don't have a key such that in the same time black and white. So the A union with B will be 52 plus 36. Now, we want to solve the question 6. So question 5, question 6. All right. So we see that A will be 5, 10, 15, and until 200. So I see that the number of the A is related to 200 divided by 5, which is 40. And the B is 9, 18, 27, and so on, and something fewer than 200. Some number. So, but I understand that B should be like 200 divided by 9, but it should be something like 36 point something. But how many inside here? Definitely I should take bracket out this one or full function, so which will be 36. And about the A intersection with B, so if I analyze this 5, 10, 15, 20, 25, so I should choose something like that in the common multiplication lowest LCM, actually LCM. So LCM of this LCM of and 9 and 5 is 45. So it starts from the 45. It's just a simple multiplication of 9 and 5 because they are not related to each other in terms of the prime factors. So I will start with 45, and then after 90, 45, 90, 135, and and we should stop until 180. So more than that, it will exceed 200. So A intersection with B is 4. As a result, the desired questions that how many elements are in A, which are divisible by 5 and by 9, or by 9. Not and, or by 9. So this will be A, or divisible by 9, A plus B, definitely A minus A intersection. So it will be 40 plus 36 minus 4. Minus 4, which will be something. All right, so now here is the multiplication principle that causes, there will be lots of questions related to this. Now in this question, it says that we have the string binary of length 4, binary means those digits that the digits are chosen to be like 0 or 1. So length 4. And if we list lexicographic order, it will be like this: 0, 0, 0, 0. Then it will be 0, 0, 1. Then it will be 0, 1, 0. Then it will be 0, 1, 1. Now here is 0, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0. Then it will be 0, 1, 1, 1. Now here I start with the fourth digit: 1, 0, 0, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, and 1, 1, 0, 0, 1, 1, 0, 1, 0, and all of that 1. So we see that 16 of them is here, but the second way of the counting without really counting is using the multiplication principles. So if we have a length for binary, so we have two choices here, two choices here, two choices here, and two of them here. So the two successive steps, okay, so so 2 here, and times here, times here, times here. So it will be 2 times 2 times 2 times 2, 2 power 4, which will be the same as the, if we count, if we really count them, it will be again 16. Like, now, have a look at this one. So permutation of this one, and definitely it will be like just patiently A, B, C, A, C, B. And I can B, A, C, B, C, A, and C, A, B, C, B, A. And we see that we have 6 of them. And if you want to use the permutation, the in objects here, so I have this one. So I have 3 choices, 2 choices. I can repeat my letters, and 1 choice here left here. So it will be 3 times 2 times 1, which will be 6, or 3 factorial. Now, the interesting problem can come here. So can I copy this here? So I see that I can list here. So A for the Anna, B for the Bin, and C for the Kai is here. And we see that if I make the circle version of these guys, so it will be A, B, C, it's here, and then B, C, A, all right, and C, A, B. It's here. So, but I can understand that this guy is like, I can bend it here. So it will be like this. And I can bend this guy here. So this will be equal to this guy here. So this guy, and this one will be actually the same thing. And the rest of this one here, this one, and this one, these will be the different combination around the circle. So in fact, we have this A, B, C, and we've got in this one A, C, B. And we really, we just have two different combination. So two different ways that they can sit around the circle. Now you can see that here A, B, C. So if this comes here and this comes here and this comes like in the position of here, so this will be A, this will be B, and C comes here. So it will be really the same as this guy here and these two together. So similarly, you can constitute the third one as well. So as a result, you've got the 3 factorial, but you need to divide it by the 3 ways that they can change the 3 ways that they can change their places. So the general formula for this one is the number is this one, but the general formula, it should be like n factorial divided by n. You can think in this way, or you can say that since the n minus 1 factorial. So actually this guy is here. All right, so you're gonna think about this guy here now. Necklace. So the necklace is the arrangement of the same as the circle, such that 2 arrangements are considered equivalent, like A, B, C, A, C, B, which if I flip this one here, like here, so this will come over this one. So this guy will be the same as the other one, because nevertheless, so the reflection is the same as the other one. So as a result, we will have just one necklace like if we consider these two guys as the same thing. Now, if we have n-barial A, B, C again around the combination of the combinatorial necklace, it will be just 1. And the general formula will be the same as the n minus 1 factorial divided by 2. All right. So here, this is the first part, and I will continue the rest of the questions in the second video.